Alright, so in this video, we're going to be looking at some more trig derivatives. These are just going to be something that you're just going to have to commit to memory. We looked at sine and cosine previously, so now we have a few more, I think about 4 more trig derivatives that we have to memorize. And we're going to be using them a lot throughout the rest of calculus and a lot of other further mathematics, so it's important that you solidify this as soon as you can. But without any further ado, let's just get into our trig derivatives here. If we're looking at the derivative of our sine of x, just as a refresher, you should remember the derivative of sine of x is just cosine x. Now here, let me do this. Let me write the originals in a different color. That way it might be a bit easier. Let's do that. Right. So if these are our derivatives that we're trying to find, I actually grouped them in a certain way where we can see, let's just keep a couple things in mind, that the sine and cosine derivatives are kind of similar, so they're grouped together. Tangent and cotangent are similar, and they go together, and so are secant and cosecant. So I kind of grouped it in that way. Also, you'll notice that I've had all the ones that start with C on the bottom row. And the reason for that, when there's no real reason, it's just organizationally, is because you'll notice that all of the derivatives of functions that start with C are trig functions that start with C. That's cosecant, cotangent, cosine, cotangent, and cosecant. They are all going to be negative. So if you remember, we had the sine of x. Sine of x is cosine x. The sine of cosine x is negative sine x. So you'll see there's a negative, right? And so again, the rest of the ones, cotangent and cosecant, the ones that start with C, also have a negative. So you can try to remember that if it's starting with C, it's going to have a negative sign there. So these go together. Now moving on to tangent. The derivative of tangent x, we could actually derive ourselves if we think about the quotient rule, right? We know that tangent x is the same thing as sine x over cosine x. So if we really wanted to, we could use the quotient rule and, go through the low d high minus high d low, square the bottom, off we go, the whole thing, to eventually get to the fact that the derivative of this is equal to secant squared x. So if we use the quotient rule and actually solve this, we would end up getting an answer of secant squared x. And so obviously we can't be doing that every single time we want to use the derivative of tangent. So just commit to memory that the derivative of our tangent function is going to be secant squared x. And now for cotangent, again, it starts with a C, so we know there's going to be a negative sign, and that is going to be cosecant squared x. So the derivative of cotangent is negative cosecant squared. So both of these ones have squares in them, so they kind of group together that way, and also, tangent and cotangent. So now moving on to secant x, the derivative of secant x is going to be equal to secant x, the same thing, times tangent x. So the derivative of our secant function is the same original function times tangent x. And now with cosecant, again, here what we see is, again, it's a C, so it starts with a negative. We have a negative sign. And this is going to be equal to cosecant x, so negative cosecant x, the same thing, times cotangent x. So you can see the secant x's function is secant x tangent x. Cosecant is negative cosecant cotangent. You can even further remember cosecant by seeing how there are two C's, right? A C and a C, and that's the cosecant cotangent. So that you could, another trick or another thing you can use to try to remind yourself that it's cosecant cotangent x. But whatever tricks you want to use, or mnemonic devices, or anything you want to use, make sure that these 6 derivatives you commit to memory, because we will be using them a lot. So you can't be, struggling to remember them in the middle of problems. It'll take up a lot of time, and obviously you can't really derive the tangent ones. The other ones are really hard to derive, especially given the time constraints of an exam. So long story short, make sure you memorize these functions. So this video is primarily here just to have all of these derivatives out in one place, not too many problems. I mean, I'll do one problem here, really just, I guess, to demonstrate how we do this and how it just really is very similar. We've been able to solve functions or find derivatives with sine and cosine because we memorized, again, the derivatives. So now if we have one that involves, for let's instance say tangent now, or cotangent, it's just the same thing. We have to just plug in the memorized derivative there. But something that you can what students may often have trouble with or is also kind of using your trig functions or using these trig derivatives on a calculator, right? We see on our calculator we have sine, cosine, and tangent, but when we look at our other functions, we kind of forget, or we don't really realize how to use that. But just keep in mind then that there are other functions, or other trig functions are just reciprocals of the others. What I mean by that is cosecant x is just the inverse of sine of x. So since we have sine x on a calculator, if we just do 1 over the function as a sine, it gives you cosine. It gives you cosecant, excuse me. And if we have our secant x, if we're trying to find secant x, we can do that by just doing the inverse of cosine. And our cotangent is just the inverse of tangent x, which we know that tangent x is just sine over cosine, which means that cotangent is also just cosine over sine. So you can use this or this, but yeah, so just use the functions, those three functions that we have available, and kind of manipulate them to get whatever it is you're looking for. But just one quick problem before we end the video is if we're trying to find the derivative of a function like this, let's say y is equal to sine x times tangent x. This is something that we would simply use product rule for, right? We think of this as the f and this is the g. If you remember back to product rule, we do the exact same thing as usual. It's just f prime times g plus f times g prime, and that'll give you the derivative. So if we're doing that here, we first take the derivative of the first part, right? If we call this f and this g. So the derivative of sine of x is cosine x. Let's say y prime, right? Y prime is cosine x times the original, which is tangent x, plus, now we leave the first part alone, so that's sine x, times the derivative of tangent x. If you remember what that is actually secant squared x. So again, why it's important to memorize these. So secant squared x. So we can leave this as our answer. This is technically the answer to this question, but we can also further simplify this. So depending on if it is a multiple choice, I know in the AP exam sometimes they have multiple choice questions, right? Or in any other exam, they might give you a multiple choice where this is further simplified or in a less simplified form. So you need to know what else could this be equivalent to. What is another option, right? Another option is if we look at it like this, cosine x, and we can see that our tangent x can be rewritten. It can be rewritten as sine x time over cosine x, and we have the rest of this as it was before. But if we have this, we can see that this cosine x and this cosine x will cancel out, giving us an answer of sine x plus sine x times secant squared x. Sine x secant squared x. So this is equivalent to this as well. They're just in different forms. The second one is further simplified. So depending on whatever the options are in the multiple choice question, you need to know that these two are equivalent. So either further simplify or undersimplify your answer to get back to this, depending on what the options there are. But anyway, that brings us to the end of this video. Again, it was just here to introduce you to the different trig derivatives that you need to know, having them all in one place. Make sure that you memorize these as soon as possible. Like I said, they come up a lot. But again, if this video was useful, please share your support by liking and subscribing. Leave in the comments any questions you may have or what you'd like to see for future videos, and I'll see you in the next one.